and 3. Done? Super. Sure. So whenever you have defect data, now understand this. This is very, very important. There are two parts. Now, what kind of data you are collecting in your process, that you need to check. Okay. Now, in some cases, in some processes, we collect defect data, and in some cases, we collect defective data. So make make two parts of your notes: defect and the defective. What is defect? Defect is nothing but, let's say, if you remember last Saturday, I gave a simple example of a shirt. If let's say we are manufacturing shirts. Now in the shirt, there could be multiple defects. Yes or no? There could be multiple defects in one shirt. Now, what could be the defect in one shirt? Let's say there could be a stain on the shirt. Okay, दाग लग सकता है shirt पे while making, in the manufacturing process. There could be buttons missing when we're stitching the buttons. Their button could be missing. Okay, or there could be the threading, the stitches basically are improper. So let's say there are three types of defects generally come in a shirt. Okay, so these are called a defect. So even one defect comes, that makes that shirt defective. That entire unit, entire product defective. Yes or no? Have you understood this? Just type yes or no in the chat box. Clear hai? So in one unit, in one shirt, in one product, there could be multiple defects. Understood, everybody? Yeah. Simple. In one product, there could be multiple defects. Now, what we are doing here is, so which data do you have? Accordingly, you have to find out which process capability analysis you have to use. Okay. Now, if you have the defect data in your quality, so you have to go to your quality department, check their data, whatever data they are collecting. Okay. Are they collecting defect data or are they collecting defective data? If they are collecting defects, then you can go for DPMO calculation. Okay. So what is DPMO calculation? Just take a same example. What is the DPMO? DPMO stands for defects per million opportunity. Okay. So the formula for DPMO is, first write the formula. I'll explain you. Number of actual defects defects and number of actual defects divided by actual defects. Okay. Divided by defect opportunity. DO stands for defect opportunity into number of units. Number of units. Whole multiplied by 10 raised to 6. 10 raised to 6 is nothing but 1 million. Okay. So whenever we write 10 raised to 6, it means 1 million, which is 10 lakhs. Okay. Now, what is this? What is this defect opportunity? We have discussed that there are 3 defect opportunities in one shirt. That means there is a potential that out of these 3, there could be 1 defect can come, 1 or 2 or 3 defect can come. Are you understanding? Now, I'll give you some numbers. Okay. So let's say, imagine I have 100 shirts I have made in my factory, and my quality person check those shirts. Okay. And every shirt has a 3 defect opportunity. Which 3? Button missing, stitching problem, and a stain. These are the 3 defect opportunity. The potential of creating defect. That is called defect opportunity. So how many DOs are there? 3 DOs. So यहाँ पे denominator में it will be 3. Okay. and there are 100 shirts which are checked. So number of units 100. Okay. So total defects opportunities is equal to 300. 3 per shirt and there are 100 shirts. So total defect opportunities we have is 300. And out of which the person found 10 defects. 10 defects he found. Okay. So can you just calculate it and give me the number into 10 raised to 6? Can you just calculate this and give me the number? Everybody should calculate this. 10 divided by 300. 10 divided by 300 into 1 million. Give me the answer quickly in the chat box. 33,000. Everybody got the same answer or someone has got a different answer then? Everybody got the same answer? 33,000. Very nice. Very nice. Chalo. So 33,000 is called DPM. Let me just, I'm just searching for a file. Yeah. So I'm just sharing one file in the chat. Can you just quickly download this file? This was shared last time as well. For the new people, this will be useful. Okay. Can you just quickly download this file? Excel file is simple. Okay. So let me also open this file. Everybody please open the file. The same file is there, which was shared last time as well. So you can use this. Okay. It is called DPMO calculator. Everybody got this? DPMO calculator. Okay. So just open this. Just type yes in the chat box. The same file which was shared if you were there last time, so you already have this file. Okay, you can download it again. Just once open, just type yes in the chat box. It's a simple Excel file. You can keep this file for any calculation in the future. Done. Everybody? Okay, the people who are traveling, just observe if you are not in a position to download and practice this. Okay, now what is the number of units? Let me just enlarge it a little so that you guys can check this out. Okay, look at this. So total number of units we have 100, right? 100 shirts we checked. Number of defects we found is 10, and number of defect opportunities is 3. Everybody has entered this data. Just type enter. Just check enter, and you will see 33,333, right? 33,333 is our defect per million. Now, what does it mean? What does it mean? It means out of 300 defect opportunities, if 10 defects are coming, then out of 1 million, how many defects you can expect? Clear hand? Out of 300, you are getting 10. Out of 1 million, how many? This is what we are doing. It is called DPMO. How many of you are clear with this? How many of you can understand this? Understanding comes from within. Clear hai? So, it's the white color. Yeah. So what we are saying here is out of 300, if 10 defects are there, so out of 1 million, which is 10 lakhs, how many defects? So this is called this number. This number we calculated, which found to be 33,333. Okay. Now, how I convert this? How do I convert this into a sigma level? What is sigma level? So when I say a 6 sigma process, when I say 6 sigma process, this 6 is a sigma level, sigma number, or a Z score we call it as. Okay, a sigma score. So how do we calculate this? So this is that number 3.33. Okay, that means currently this process is 3.33 sigma process. Are you clear? Are you understanding this? Okay. Now, so if we reduce the number of defects by doing a project, if we reduce the number of defects, okay, so as the number of defect reduces, our DPMO score will go down and our sigma score will improve. Clear? Now look at this. Yeah. Yeah, Mr. Amit, just put your numbers over there. Total number of shirts, 100. How many defects we found? 10. And how many opportunities per unit we have? 3. Correct? So here we can have 100. Just enter the data, you will find DPMO is equal to 33333, which is 33,333. Here, which in turns, what is the sigma score? Which is 3.33 sigma. That means we are at 3.33 sigma process. Okay. Now, if by doing a project, if we reduce the number of defects and do the sampling again, and this time the quality person finds 5 defects out of 300. What will happen to my DPMO? Will my DPMO go up or go down? Type in the chat box. If instead of 5, the quality person finds only 5 defects, what will happen to my DPMO? Type in the chat box. Down or up? D for down, U for up. Type in the chat box. DPMO will go down. Defects per million will go down. Very simple. Just put enter. Look at this. So DPMO from 33,000 has gone down to 16,000. Exactly half. Exactly half. And what has happened to sigma level? Sigma level has gone up from 3.33 to 3.62. Now my process is 3.62 sigma process. Now what is the formula to calculate this? The formula to calculate is this is, then note down this formula. एक्सेल में ये फॉर्मूला है आपके, आप देख सकते हो. इट इज नॉर्म साइन v. राइट दिस डाउन. नॉर्म साइन v in bracket 1 minus in bracket again DPMO number, whatever DPMO number you have calculated, divided by 1 million, which is 10 lakhs. Bracket close, plus 1.5. This is the formula to calculate sigma. From DPMO number, you can calculate the sigma number with this formula. Is equal to norm sine V in bracket 1 minus in bracket again DPMO number, and then so it is already there in this. If you click on that, you will find out that yes, this is 1.5 sigma shift. Absolutely right. So if you are taking a short-term process capability, just write plus 1.5. If you are taking long-term process capability, you need not to add this 1.5 sigma shift. Okay, I will cover this someday, some other day. But this is the formula.
Sir, what is the sigma shift? 1.5 sigma.
Yeah, so this is 1.5 sigma shift is, so there is something called short-term process capability and long-term process capability. Okay, in the short term, see, in a very short, I'll explain this. See, short-term process capability, just like a sample. You are taking a small sample, correct? Now, in a sample, the variation is very less. So the standard deviation is very less. Understand this? The variation is very less. So what they say, in a short term, if your process capability is, let's say, 4 sigma, understand this, huh? Then they say that long term, your process capability becomes 2.5 sigma in a long term, because in long term, there are a lot of variations which impacts, and that reduces your process capability. And how much? On an average, it is 1.5 sigma. That's why it is, by standard, they say 1.5 sigma shift, you can say, from short term to long term. Okay, clear? Eh? Yeah, everybody clear till now? Just type yes in the chat box. Okay. Now, everybody open any Minitab file, which is a blank file. Okay, any Minitab file. Yeah, Nivedita, I'm sharing my screen. You are not able to watch the screen, not able to see the screen. Everybody can see my screen, right? Just give me yes in the chat box. Yeah, good, good. Okay, Nivedita, can you just check if you're on the mobile phone, maybe just scroll it up. Some other window will have this sharing. Okay. No, long term, the sample size will always be more than the short term. Okay. Yeah, only difference between short term standard deviation and long term is the formulines of standard deviation. Long term process capability we use in the denominator we use n, and in the long term process short term process capability we use n minus 1. Okay, I'll explain you some other time. Let's focus on our day to day, because Poisson and binomial distribution we have to cover. Okay, chalo. So everybody open this new file, new Minitab, blank sheet. No, not standard deviation, Nivedita. Is the process capability that shifts, not standard deviation. Okay, process capability shifts. So long-term standard deviation does not shift. Long-term process capability, you can say long-term process capability. So long-term process capability is equal to short-term process capability plus 1.5. That will be a right way of putting it. Okay. Now, chalo, coming back to this. Now I want to find out. So there is something called Poisson distribution for a defect data we will calculate. So I don't have data. So what I'll do is go to help menu. Now everybody just follow with me. Okay. Go to help menu, go to stat guide. Okay. Go to stat guide. Click on stat guide, everybody. Go to help menu, go to stat guide. Now I'll show you. So this window will appear. Okay. So there is a Minitab, guide window will appear. Minitab guide. I'll just click on that. I'll explain you. This window will appear. Everybody with me till now, just type yes in the chat. Go to help, click on stat guide, and you will get this window. Anybody behind me? If you have the Minitab and laptop, please follow this way. This is very, very important. You will get a lot of insight. Okay. Go to search and just type Poisson. Poisson. जो हम लोग जहर बोलते हैं ना, पॉइजन, उसमें सिर्फ एक एडिशनल एस लगा दो, दैट बिकम्स पॉइजन डिस्ट्रीब्यूशन. पॉइजन. Some people call it as Poisson distribution. Some people call it as Poisson distribution. Doesn't matter, the same thing. Okay. Just type Poisson, Poisson, and just enter. Okay. So on the left hand side, you will find a lot of information, lot of case studies related to Poisson. So right now, today we are studying process capability. So can you see this third one, summary capability analysis Poisson? Just double click on that. Summary process capability Poisson. Third one, the third option from the top. Double click on that. On the right hand side, you will receive some information about it. Everybody with me till now, just type yes in the chat box. Anybody behind, let me know. I will slow myself down because understanding is more important. Okay. Again, now understand this. So where are we using this? Instead of DPMO, we can use something called DPU as well. I'll just quickly touch upon this topic. So instead of DPMO, which we have just seen, instead of DPMO in Minitab, there is something called DPU. And for that, we will use this Poisson distribution. Okay. So this is also one way of calculating process capability, DP. Yeah, Vijay Kumar ji, I'll explain you again. Okay, I explained you a little earlier. So DPU is defect per unit. Okay, defect per unit. And with the help of Minitab, we are going to use this with the help of Poisson distribution. Okay. Sample lead to zero score. Uh, just go one by one. Let's go one by one together. Okay. यहाँ तक हो गया. So just try to understand this. What you can say first. Understanding case study. Okay, case study says there is a wire manufacturer. Okay, electrical wire manufacturer, and that person is concerned about the effectiveness of the insulation process. Okay, the quality engineers randomly select the length of the electrical wire and test them for the weak spot of the insulation. Okay, so quality engineer with some equipment, they are checking the weak spot and they have collected some data. And this data is basically recorded in this data file folder, and the name is wire.mtw. Everybody can read this. Just give me yes in the chat box. Wire.mtw. MTW stands for Minitab worksheet. Minitab worksheet. And the name of the worksheet is wire, because we are just checking the wire weak spots. Everybody clear? So every weak spot is a defect. In this case, every weak spot is a defect in the wire. Clear, everybody? So here only one defect is there, and that is called a weak spot. Just type clear in the chat box if you have understood this. Understood the scenario? So there is a wire and they are checking the weak spots where the insulation is weak. Clear? Correct? So where the insulation is weak, there can be some electroculation happen. There could be some leakage of the current can happen. So there could be a lot of defects, lot of challenges can come. So they want to check how many defects are there. Okay. So what we do, just go back to the worksheet once again. Go back to our blank worksheet once again. I'm just going back. Now, where we can find out this? Go to file. Everybody just follow this procedure. This is very, very important. File, open worksheet. Click on file, click on open worksheet. So this window will appear. Now, just observe here at the bottom. Anybody behind, let me know that I'm behind. So observe here at the bottom. Look in Minitab sample data folder. Okay. यहाँ पे आप देखो. Look in Minitab sample data folder. Okay. Everybody with me? Just double click on that. Double click on this symbol. So all the sample data folder will get uploaded on your software. Okay. Now, once you double click on that, then in the file name, you just click and say wire, W-I-R-E. You can select W-I-R-E. You will find this file and just open this file. Okay, I repeat again, go to file, go to open worksheet, click on this, look in the Minitab sample folder, just double click on that. All these folders will get downloaded on your system. In the file name, you just click and just type wire, W-I-R-E, and just select this file and click on open. Everybody done? Just type yes in the chat box so that I can proceed. Everybody with me? Yes, 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 yes. Anybody behind, let me know. Okay. Doesn't matter if you're behind, we will wait for you. Very good. Chalo. Meanwhile, just give me a second. Okay. Poonam, I'll just explain you once again. Just focus here. Just a second. Just give me a second. I'm just arranging the file once again. Okay. Now, Poonam, what you can do is you can just download this Excel file. Everybody, you can download this Excel file as well. And I'll come back to this. The same file, the same data. And now you can copy and paste this data in any Minitab software. Okay, Minitab blank worksheet. Here, everybody just download this file. Very good. Chalo, let me now come back to Minitab again. Yes. Oops. Okay, chalo. So now, how do you use this Poisson distribution? And now what is the data? Let's try to understand the data. So here, the first sample, they checked 132 meter length and they got 2 weak spots. So 2 defects in 132 meter length. Second sample, 130 meter sample, they found 4 weak spots. And similarly, they have got some 100 or some data points. Okay, everybody understood the type of data here? Okay, so it's a wire company and they're identifying defects as the weak spot of the insulation. Take a very common this thing example. Now, how do you find out the Poisson distribution here? So go to stat, process capability, mein, quality tools, capability analysis, Poisson. Just follow this step one by one. Go to stat, quality tools, capability analysis, Poisson. Stat, quality tools, capability analysis, Poisson. Done. Click on that. So this window will appear. Okay, everybody with me till now? Stat, quality tools, process capability, analysis, Poisson. In the Poisson distribution, this window will appear. So in the defect section, select the weak spots because you have to find out the defects from the weak spots, right? So this is a column. Double click on that. Weak spots will get selected. Now, do we have the constant size? No, we don't have the constant size. So you have to click on use sizes in and just select the length wala column, C2 over here. Okay. Historical, we don't know in historical data. So just keep it blank. Target, let's keep it 0 because we want 0 defect. Okay. Everybody with me till now, just type yes in the chat. Here hai. Just feed the data as displayed on your screen. In the defect, just select the weak spot column. In the sample size, in the use size, just select the length column. Just give me yes in the chat box. Just give me yes in the chat box if you are with me. Okay. Just click OK. Wow. How many of you got this? Yes. Now, do not worry about all these statistical things. It's very simple to understand. This is a U chart. How many of you remember U chart from the control phase? Yes. Whenever we have the defect data and whenever we have the sample size which is varying when we use the U chart, right? So this is the process, whether the process is stable or not. So only one data point we are finding outside of the control limit. Otherwise, the process is more or less same or stable. Okay. So this graph is called cumulative DPU. What is DPU? Defect per unit. Defect per unit. What is defect per unit here? Just try to understand this. Let's say every data point here, first data point says, let's say for example, 130 meter and there are 2 defects. Okay, second data point says 134 meter and there are 4 defects. So 1 unit here is 1 meter. Okay, so in 130 there are 2 defects, or in 134 there are 4 defects. So how many defects will be there in 1 meter? So defects per unit in this case becomes defects per meter, because we are collecting the data in the meters. Okay, so in this case, on an average, we are finding that the defects per meter or defects per unit is 0.265. That means every defects, we have 0.265 defects on an average, DPU. Are you clear? Just type yes in the chat box. And this is your process capability by using Poisson distribution. Simple. Just check the DPU, just like your DPMO. Just like our DPMO, we just check this number called DPU. That's it. This number. Okay. And this is before improvement. So then you will do the project to reduce the number of defects. To reduce the number of defects. Okay. So once you do the project and reduce the number of defects, this DPU should come down. And that is how you can compare. Are you clear? So I'll repeat again. How do we do that? How do we do that? So I'll go to the data once again. So this is the data. So I go to stat quality tools, capability analysis, Poisson. When do we use Poisson? When we have the defect data and I want to calculate the process capability of the defect data with the help of Minitab. There we can use the Poisson distribution process capability. So you can click on Poisson, select the defect data in this column of defect, select the sample data in this column and just say okay, and you will find this process capability. Just check the DPU number and that's your process capability. That's it, very simple. How many of you are clear? Just type C in the chat. C for clear. This is called the Poisson distribution process capability analysis by using Minitab. Clear hai? Yes, no? Okay. Just go to the recording once again. This recording will be shared with you in the masterclass archive. Go to the recording once again and just follow the step by step and you will get this. Different example for understanding. Yes, there are so many examples you can take. Okay. In our what you can say, one example you can just homework for the homework sake. Okay. For the homework sake, you can take example of a U chart, any U chart example which is given in your curriculum. Okay, you can check the curriculum of green belt or black belt, any U chart example that you can follow and check the Poisson distribution. Okay. Steps are clear. Just please explain one's chart. Okay, chart का explain करते हैं. This is a control chart. Understand? एक बार मैं chart को explain करता हूँ. This is a control chart. Simple control chart which is called U chart, which we have studied in the control as well. Okay. Now this chart is the sample size against DPU. Now why this chart is done? Because we want to check whether any kind of deviation we are finding if we increase the sample size. Okay. Now the flat red line indicates that there is no significant change. When we are changing the sample size, there is no significant change happening in the DPU. Otherwise, we would have received something like this. That I'm increasing the sample size, my defect per unit is increasing. Like that kind of trend we would have seen, but there is no such trend observing. That is what this graph is telling. Now, what is this cumulative DPU graph? Cumulative DPU graph says tells us that So for example, let's say this is first sample. Just try to understand this. This is the first sample. Okay. First sample क्या है? Imagine two defects in 130 meter. This is sample size, and this is your defect. Okay. So what is cumulative defect per unit? Second is, so they will calculate 2 divided by 130. So whatever is the value, this will be the value. So this is 0.015. So 0.015 will be the answer. So this is the first data point, cumulative defect per unit. Clear? Now the second data point is what here? In this case, let's say 4 out of 132. Now the cumulative is 6 defects and in 262 meter sample. So then they will do 6 divided by 262, whatever is the number. So this will be the second data point. Are you understanding this? This is called the cumulative DPU. Are you clear? Just type yes in the chat box. Then the third data point, let's say third data point is, let's say one defect in 120. So they will add this defect 7 and this will become what? 382. Okay. So 7 divided by 382, that becomes the third data point. Clear line? Yeah, why this is a crooked line? This is a crooked line because what happens is it stabilizes over the period of time. Understand it? It stabilizes over the period of time. So earlier, the DPU remains very low. As we increase the sample size, it increases and stabilizes. Okay, so DPU graph, you will always find like this. Clear head? Okay, so this is the DPU. Now, this is just like our DPMO number. We calculated DPMO manually. Similarly, this is your DPU, and this also you can consider as a process capability. Now, how do you find out the sigma level of this? How do you find out the sigma level of this? Very, very simple. The same formula we can use. Okay. So the same Excel sheet I have given it. Just can you open the Excel sheet? हम लोग तो sigma level भी calculate करते हैं. Okay. We'll do the Excel sheet. Open करो. So sigma level calculate करते हैं पहले. Open the same Excel sheet which I have just forwarded to you guys. The Poisson distribution wala Excel sheet. Okay. Let me see if I have that. Stop this. Clear all the drawings. And let me see if I have this Excel sheet with me. I don't have. I think this will be on my right. Okay. Chalo, so everybody open the Poisson distribution Excel sheet. The same data I have just copied in the Excel sheet, or you can just copy from the mini tab and put it in the Excel sheet. हम लोग manually करके देखेंगे. ठीक है? Okay. So you are asking about the UCL, the U chart wala. See why the control limits are like that? Because every data, the sample size is different. See here. Every time the sample size is different, and that is the reason the control limit is calculated for every point separately. And that's why the control limits are like this. Because every control limit is separately calculated for every data point. Okay. Yes, that is the reason it looks like this. Okay. Everybody open this file. Just type yes in the chat box. Yeah, let me share my screen as well. Yeah, Excel में फिर से एक बार करता हूँ. Okay. Anybody can share the Excel file once again to Nivedita in the chat box, please. The same Excel file, the Poisson distribution. The name of the file is Poisson distribution. Can you just quickly somebody do this? Because I have to again close this file and share this. Otherwise, I will not be able. Yeah, definitely. We will open for the question answer. There we can ask the question. Okay, yes, thank you very much. Thank you very much, Vijay ji, Kingshu ji. Thank you very much. Yeah. So Nivedita, you can just download this file. Okay, now try to understand this. Same data. Okay. Now we will calculate the sigma level over here. Okay, to calculate a sigma level, first let's calculate the summation of both of this. Okay, so calculate a summation. So summation of all the defects पहले करते हैं calculate. Calculate this entire sum, the defect data. Press enter. So you have 329 defects total, right? And what is the total units we have? So again, select this. I'm just using a very basic Excel. Everybody with me? Done the summation. So 12,406. Everybody got this? So I'll just wait for you. Just do the summation of this. Excel open करो, दोनों का summation करो फटाफट. Clear? Now, how will you find out the DPMO here? DPMO, or you can say DPU itself. DPU calculate करते हैं ना, defects per unit. DPU equal to 329 divided by 12,406. Can you just do this calculation? Very good. Super. So let me just do this calculation over here. So this is equal to this divided by this. Very simple. And this is my DPU. हाँ, yeah. ठीक है. Alt plus. Otherwise, I could have just dragged this, no? ठीक है, clear है? Everybody got this DPU? 0.026 defect per unit. Everybody got this? Just type yes in the chat box. Yet now you can put this sigma formula over here. इसको sigma formula डाल दो. Put the sigma formula here is equal to norm sin V in bracket 1 minus in bracket again this DPU number, follow with me, is equal to norm sin V, NORMSIN in bracket 1 minus again bracket this DPU, just select this DPU number divided by 1 million. Just check the zeros, okay? There should be 6 zeros. Bracket complete plus 1.5. Check the formula once again. Norm sin V in bracket 1 minus in bracket the DPU number divided by 1 million, bracket close plus 1. Clear hai? Just click OK. Everybody got this? Is it 6.9? Is it? Everybody got this? 6.9 aaya kya? Everybody got this? So generally you can, so see what you can do is, you can consider this, just remove this plus 1.5, just make it a long-term process capability. Say okay, it will become 5.4. So हम लोग ZLT के बारे में देखेंगे, ZLT which is 5.4. So we can say that, so I've just removed that plus 1.5. Okay, from this equation, I've just removed this plus 1.5. Just press enter, you will find 5.44. So this is your sigma level, which is 5.44. This is your z-score. Clear? So this is your long-term z-score. Your short-term z-score is 6.9. Got it? This is your long-term process capability, which is 5.44, and short-term is 6.9. Are you clear? Just type. So you can consider this as well, your process capability. You can consider this as well, your process capability. You can say that my current process is 0.02652 DPU process, defect per unit process. Okay. Or you can say that my current process is 5.44 sigma process. So both ways it is the same thing. And the same process you have to do after you have improved the process. The same process. If you are using DPU, use DPU. If you are using the sigma, just use sigma. That's it. Got it? Just type yes in the chat box. Clear, everybody? This is manually also we have calculated. Clear? Just watch out this. I will give all these resources, these all Excel files, all these Minitab files, everything I will give you. Just watch this recording once again. Do this practice on your own. That will make a lot of, your fundas clear. DPMO formula same hai. Number of actual defects divided by defect opportunities into number of units. 3103, yeah, just a second. I'll just click on the cell. So this is the cell. This is the formula. Is equal to norm sine V in bracket 1 minus in bracket DPU divided by 1 million. Bracket close, bracket. Clear? Yeah, because this is a long-term process capability. If I add 1.5, this will become 6.9 sigma. That will become my short-term process capability. That means in a short term, my process is more than 6 sigma capable, but in the long term, it is 5.44 sigma capable. Clear? Just type yes in the chat. See, it requires a little bit of practice. Initially, you might find it a little difficult, but practice makes you perfect. No, you can calculate both. आप दोनों भी दे सकते हो. Short term, this is process capability. Long term, this is process capability. That's it. Okay. Clear? Very good. Chalo, let's move to the Poisson distribution now. What is Poisson distribution? Open the same Minitab file. Open the same Minitab file which we have used. The same Minitab file we will use again. Open the same Minitab file. Go to the data, or you can open. Now this is Poisson distribution. What we have done, Sridharji, is a Poisson distribution. Okay. Now I am explaining you binomial distribution. Now when do we use Poisson? When you have defect data, when we use Poisson. When we have defective data, then we go for the binomial distribution. Okay. Now let's follow the same procedure. Go to help. Go to stat guide. Now remember the same procedure. Okay. Go to search menu. Help, stat guide. Search menu. Everybody with me? Help, stat guide. Click on the stat guide. You will come to this. Instead of Poisson, delete Poisson. Write binomial. B-I-N-O-M-I-A-L. Binomial. Binomial. Because it is two. Binomial between, because two. Discrete data में क्या करते हैं हम लोग? Accept, reject. Defect. Wherever we have defective. See what we have? Either we accept it or we reject it. No, so whenever we have the defective data, we say 10% rejection. But what does it mean? Out of 100, we have rejected 10 pieces. So 10 defective out of 100. Correct? That's called binomial. Accept, reject. Yeah, I'll share the first step once again. Okay. Open any Minitab worksheet, any blank Minitab worksheet like this. Go to help menu and go to stat guide. Help stat guide. Click on stat guide. Everybody help menu stat guide. Once you click on stat guide, you will reach to this window. This window you will reach. Over here, go to search, click on search, and in the search bar, just type binomial, B-I-N-O-M-I-A-L, binomial, and say OK. Because we are doing binomial process capability, just click on the second option available, summary capability analysis binomial. The second option in the search. Okay, double click on that. Double click on that, you will get this. So first, understand that understand the what you can say the case, and then we will deep dive into this. Okay. So a call center coordinator wants to assess the capability of the call center answering process, the call answering process. Okay. The total number of incoming calls and the non-answered calls. Understand this. So what is the problem here? There are, let's say, 100 calls coming, but because of the load, there are few calls which are being missed out. So they have collected the data of unanswered calls, which are defective. So the incoming call is the input, and unanswered call is okay. Unanswered is a defective call. Are you clear? Data samajh mein aaya? And then the data file is, the name of the data file is unavailable.mtw. Unavailable at mtw. This is a data file. Remember the name of the data file, unavailable.mtw. Okay. Now the same procedure, open any blank worksheet or go back to the same worksheet. We'll do that. Go back to the same Poisson worksheet. Go to file. Click on open worksheet. Click on open worksheet. Now, because we have already uploaded all these sample data folders, now just have to click over here and just type unavailable. Unavailable. The moment you type unavailable, you will find this file over here. Just click on open. It will open in another file. Everybody got this? Just type yes in the chat box. If you got this, just type yes in the chat box. Fantastic. Now try to understand the data. So they have collected the data in one day. Let's say 858. So 5th of August, the data was there. 1908 calls came in, out of which 438 calls were not answered. So their defective calls are 432. Second day, 1912 calls came, out of which 390 calls did not get answered. So this is where the defective data is given. Okay. Now we are going to do the process capability analysis by using Poisson distribution. Okay. Now go to stat, the same flow here, stat, quality tools, capability analysis, and in this case now not Poisson, it is binomial. Whenever defective data is there, it is binomial. So you can read it out, no? Once you put a cursor over here, it will say determine whether the percentage of defective item. So this is called the binomial. Just click on that. The same flow. Yeah, I have not made this file, Poonam. But if you have the Minitab, you can go to help menu and go to the stat guide and just search for the binomial. The second option, you will find this file. Okay, if you have the data folder already uploaded, just type unavailable.mtw. You will find this file, unavailable.mtw. Okay, you will find this file. Now just click on binomial here. You will get this window. The same process, nothing changes. Okay. So in the defective data, you have to select the unavailable calls and click on the huge size in and click on calls. Okay, call column ko select karo. That's it. Okay. And defective should be 0. Let's keep it at 0. Let's keep it as 0 and just say okay. Everybody, defective makes select the column unavailable, and in the other sample size column select karo calls ka and just say okay. And the same similar kind of output will come. Only thing is that there are two different things which we are coming. Now there are three parameters we are coming. Okay. What are the three parameters? Very simple. The same thing. This is a control chart. This is the histogram. This is the cumulative defective percentage which I explained you. And this is the rate of defective. Okay. When I increase the sample size, is there any impact on my percentage defective which is coming up? That is what. So this is a flat line which shows there is no impact on the percentage defective when I increase the sample size. Okay. So here there are three parameters we have to use. What are the three parameters? And you can use all the three parameters or either of these three parameters. The first one is this one called percentage defective. So in the binomial distribution, you can use percentage defective as your process capability, or you can use ppm. What is ppm? Parts per million as your process capability, or the same software will give you the z-score directly. So you get the process z directly calculated. So either of these three you can check. Okay. So this one, the ppm is 2,26,427. Percentage defective is 22.64%. If you convert into per million, it becomes 26,427. And when it comes to the z-score, the process is 0.75 sigma process, which is a very poor process capability. Are you clear? Just type yes in the chat box. So this is how you can check the Poisson. When you have the defect data, go for Poisson distribution process capability. Whenever you have defective data, go for binomial distribution process capability analysis. ppm means defective per million. It is part. Part का मतलब है defective product, not defects. Defective per million. Okay. So ppm is also called as I said earlier, it is also called a dppm. Lot of people get confused between ppm. See, ppm and dppm are the same thing. ppm stands for parts per million and dppm stands for defective parts per million. Both are same thing. Here, so you can use Poisson distribution in terms of defects, binomial distribution in terms of defective, or otherwise you can use simple Excel sheets and calculate a DPMO, or the Excel sheet I have given you to calculate a DPMO, that also you can use. Are you clear? Just type yes in the chat box. Clear hai everybody? Yes, no, yes, no. Clear? It requires practice. 1 time, 2 times, 3 times, 4 times, you will get it completely clear. Clear? Yes? So whenever you have the defective data, try to do this in the binomial distribution as well. And whenever you have the defect data in your own process, take that data, put that in Minitab and do this analysis and try to understand, try to correlate with this. Okay. See, the same things basically we teach in the data science, the data analytics. Okay. The same fundamentals are taught, binomial and Poisson distribution. Yes. So that was the topic we have. So my recommendation is, it seems very difficult, but when you do it on your own, you'll find it so easy, super easy. P chart, yes, P chart. When we use P chart, when we have the defective data and the sample size is varying, okay. And when we use the U chart, when we have the defect data and the sample size is varying. So let me just show you both. So this is the binomial And let me open up the Poisson distribution as well. So this is the Poisson distribution. Okay. So you have got both these distributions. Of course, both the datas were different. Okay. So look at this. So here we have, so just for the summary, just for the last summary here, whenever we have the defect data, so whenever we have the defect data, go for U chart. And whenever we have the defective data, go for P chart. Okay. Whenever we have the defect data, go for Poisson process capability analysis. Whenever we have the defective data, go for binomial process capability analysis. And in the Poisson process capability analysis, it is denoted in DPU. Okay, mean DPU. The average DPU is the measure of Poisson process capability. And in the binomial process capability, you can mention your process capability in percentage defective or PPM or process Z. Okay, these are the three parameters you can show your process capability. Okay, clear hai? Just type yes in the chat box. What will come under defective in the so if you have the defective data, go for binomial. If you have the defect data, collected data is the defect data, go for Poisson. And I always say go for defects data and not defective. What is the reason? What is the reason? The reason is, see, understand this. Defective mein kya problem hai? Just see the scenario. Okay. Why you should always collect the defect data and not the defective data? Because let's say I'm checking the shirt. Okay. The moment I find one defect, I will declare that shirt as a defective shirt. Yes or no? I may not find the other defects in that. And that is the biggest problem. I might have multiple defects in one shirt, yes or no? And that's what happens. That's why we always have to collect the defects data, count the defects, number of defects. Do not declare the product defective in one defect itself, because one defective can have multiple defects in that. Okay, and that is the point. Clear? Yes, actually defects is always recommended. Yes, one defective can have multiple defects. So that's why always we recommend that you go for the defect data, go for Poisson distribution. Okay. Yeah. Yeah. If you have any target, you can put the target and against the target. Now, both these cases, if you observe both these cases, we keep our target as 0. But if your organization has some internal target, or your customer has given you a target of percentage defective, if they can accept, then that target you can take, and accordingly your what you can say, specification limit will shift. Okay, and accordingly your process capability will shift. Okay, that's it about the Poisson and binomial distribution. I believe you got some deeper understanding about it and got some new idea about this. Yeah. Okay, now honestly